In our last video, we saw why requirements must come first in model-based systems engineering. Without them, even the best-looking models quickly lose direction. But here's the next challenge most teams face. Just having requirements isn't enough. They have to be good requirements, clear, verifiable, and tightly connected to the system's purpose. One of the most common issues in systems engineering isn't modeling, it's requirements. Teams spend time building architectures, defining interfaces, and modeling behavior, but the requirements that drive those decisions are often unclear, vague, or incomplete. And when requirements are weak, everything built on top of them becomes unstable. Did you know that poor requirements gathering and management contribute to around 35% of project failures? And overall, studies show that a large percentage of projects, sometimes up to 70%, fail to meet time, budget, or quality goals, with vague or unclear requirements being one of the top culprits. That translates to billions wasted globally every year. The good news? Writing clear, high-quality requirements is a learnable skill. When done right, they act like a perfect blueprint. Everyone, from product owners and developers to testers and stakeholders, understands exactly what's needed, reducing misunderstandings, scope creep, and expensive rework. Poorly written requirements are one of the hidden reasons MBSE projects struggle. They create ambiguity that shows up later as rework, failed verification, and models that no longer reflect reality. In this video, we'll walk through exactly how to write strong system requirements. We'll cover the qualities every good requirement must have, practical writing techniques, the most common mistakes to avoid, and how requirements fit into MBSE. When you finish watching, you'll have a repeatable process that turns vague stakeholder needs into requirements that truly drive successful model-based systems engineering. Let's dive in. Characteristics of a good requirement. So what makes a requirement good? At its core, a requirement defines something the system must do, or a constraint it must satisfy. It captures intent, not implementation. A requirement should answer, what must the system achieve, not how should the system be designed. That distinction is critical. When requirements include design decisions, they limit flexibility and introduce risk. Good requirements define the problem clearly. They do not prescribe the solution. Standards organizations like INCOSE and IEEE 29148 have studied this for decades and identified the same core qualities that separate effective requirements from the ones that cause problems. Here are the 7 that matter most in MBSE. Necessary. The requirement must directly support a stakeholder need or higher-level requirement. If it doesn't answer why does this exist, it doesn't belong. Unambiguous. It can be read only one way, no room for interpretation. Singular. One idea per requirement. Never combine 2 capabilities into one statement. Verifiable. You must be able to prove, through test, analysis, inspection, or demonstration, that the system meets it. Feasible. It must be possible with the available technology, budget, and schedule. Traceable. Every requirement links back to its source and forward to the behavior, architecture, and verification activities that support it. Complete as a set. Together, the requirements fully describe what the system must achieve without gaps. Good requirements share a few key characteristics. First, they are clear. Anyone reading the requirement should interpret it the same way. Second, they are verifiable. You should be able to test whether the requirement has been satisfied. Third, they are unambiguous. Use precise language. The system shall for mandatory items, strong commitment. The system should for desirable but not critical. Avoid weak or subjective words like fast enough, efficient, user-friendly, robust. These mean different things to different people. Fourth, they are necessary. Every requirement should exist for a reason, tied to a stakeholder need. Fifth, they are traceable. Each requirement should connect to a stakeholder need, system behavior, verification method. A requirement that cannot be verified or traced is not complete. These characteristics aren't just nice to have. In MBSE, they become the anchors that keep every block, activity diagram, and interface consistent with the real system intent. Types of requirements to consider. Not all requirements look the same. Understanding the main types helps you write them better and organize your model. Functional requirements describe what the system must do. Performance requirements describe how well it must do it: speed, accuracy, capacity. Interface requirements define how the system connects and exchanges information with external systems or users. Non-functional or quality requirements cover reliability, safety, maintainability, security, and usability. In your MBSE tool, you might model each type using different requirements diagrams, but they all start with the same disciplined writing approach. Effective requirement statements. The actual wording matters. The clearest format used across industries is simple and consistent. The subject shall action verb, object, measurable value, under, condition. Good examples. The radar system shall detect a 1 meter squared target at a range of 150 kilometers with a probability of detection of at least 0.9 under clear weather conditions. The vehicle shall accelerate from 0 to 60 miles per hour in no more than 6.5 seconds when operating at sea level and 70 degrees Fahrenheit. Compare that to weak statements. The system shall be user-friendly. What does that mean? The vehicle shall be fast. How fast? Under what conditions? Use strong action verbs: shall detect, shall transmit, shall withstand. Avoid weak words: user-friendly, adequate, maximum, as appropriate. Always include the measurable value and the conditions under which the requirement applies. Practical tips and techniques for writing better requirements. Here are battle-tested tips to elevate your requirements writing. 1. Start with stakeholder collaboration. Interview users, run workshops, and review drafts together early to catch gaps. 2. Be concise and use active voice, short sentences. Example: the system shall send a confirmation email within 5 seconds of order placement. Not, an email confirmation is sent to the user after they place an order, and it should happen pretty quickly. Focus on what and why, not how. Describe the need or outcome. Save technical design decisions like choosing a specific framework or database for later architecture docs. Make every requirement testable. Pair it with acceptance criteria. Ask, how will we know this is complete and correct? Separate functional and non-functional requirements. Functional, what the system does, for example, process a payment. Non-functional, how well, performance, security, scalability, usability. Prioritize effectively. Use Moscow, must have, critical for success, should have, important but not vital, could have, nice to have if time allows, won't have, out of scope for now. Add visuals and context when text alone falls short. Define terms in a glossary. Avoid assumptions. Create one shared glossary for acronyms, business terms, etc. Write for your audience. Tailor detail level. High level for executives, detailed for developers and testers. Pro tip: always review with a fresh pair of eyes or peer. If you can't easily write a test case for it, rewrite it. Common mistakes and how to avoid them. Even experienced engineers fall into these traps. Here are the 4 most common ones I see in early MBSE projects and the simple fixes. Embedding the design solution. The system shall use a 32-bit processor. Fix: state the need. The system shall process data at a minimum rate of 1.2 gigabytes per second, and let the architecture team choose how. Unverifiable or vague language. Example: the system shall operate quickly. What does quickly mean? Fix: replace with measurable criteria. The system shall respond within 2 seconds. Gold plating: adding nice-to-have features that aren't tied to any stakeholder need. Fix: every requirement must trace to a validated source.
combining multiple ideas or overloading requirements, trying to capture multiple ideas in one statement. This makes them difficult to test and trace. Each requirement should express one idea clearly. Example, the system shall detect and track and display targets. Fix, split into 3 separate, singular requirements. Review every requirement against these mistakes before you baseline the model. Deriving requirements from stakeholder needs. Good requirements don't appear out of thin air. Start with stakeholder needs, the why, from users and customers. Use operational scenarios and use cases to explore how the system will be used. Then refine those needs into precise, measurable system requirements.
This is exactly where structured methods like OSIM shine.
The method begins with stakeholder needs analysis, translates them into clear system requirements, and only then moves into behavior and architecture. Every step maintains traceability, so nothing gets lost. Once requirements are defined, they guide the next steps in MBSE. Requirements lead to behavior. What functions must the system perform? Behavior leads to architecture. What components are needed to support those functions? This progression keeps the system aligned with its intended purpose. Without strong requirements, this chain breaks, and the system begins to drift. Writing good requirements is not easy. It requires understanding stakeholder needs, translating intent into measurable statements, avoiding assumptions, and maintaining consistency across the system. This is why many teams struggle, not because they lack tools, but because requirements require discipline. In traditional systems engineering, requirements are often stored in documents. In MBSE, requirements are no longer just text in a document. They become part of the model. They connect directly to behavior, structure, interfaces, and verification. This creates traceability. When a requirement changes, you can see what parts of the system are affected. Instead of guessing, the model shows the relationships. Requirements become the foundation of the entire system model. You create formal requirement elements with ID, text, and attributes. You derive requirements, satisfy, and verify relationships directly in the model. You generate requirements diagrams and traceability matrices automatically. When a requirement changes, the model immediately shows which parts of the behaviors, components, and test cases are affected. For example, a requirement may trace to an activity diagram that describes system behavior, a block in the architecture, a verification test case. This traceability ensures that the system remains aligned with stakeholder intent. When a requirement changes, engineers can immediately see which parts of the model are affected. That visibility is one of the biggest reasons teams adopt MBSE. This is where MBSE provides real value. If you want to see this exact workflow, stakeholder needs to system requirements to traceable model elements, we walk through it step by step with a real example in our SSA OSIM training program. The link is in the description. Good requirements are the foundation of good systems. When they are necessary, unambiguous, verifiable, and traceable, your model stays aligned from day one through verification and beyond. If requirements are weak, everything built on top of them becomes harder. If requirements are strong, the rest of MBSE becomes significantly more effective. Poor requirements create rework that no amount of fancy diagrams can fix. If you're ready to move from struggling with requirements to confidently building models that deliver real engineering value, our SSA MBSE training program shows you exactly how, including the full OSIM workflow with practical examples you can apply immediately. Link in the description. And if this video helped, subscribe for more MBSE Simplified, model-based systems engineering without the complexity. If you're continuing your MBSE journey, we'll build on this next by looking at how requirements translate into system behavior. See you in the next video.